All right, good day, everyone. Welcome to the feedback class. I want you all to confirm that you can hear me. Can you just type yes into the chat box so that I can confirm that you can hear me? If you can, type yes into the chat box. Okay. I have Chidera's confirmation. Can I have maybe one more? Okay, one. Thank you. You can hear me, Yusuf. All right. So we can go on. I can see that everyone can hear me. So last week was about current electricity, electric fields. So whatever question you have there, you just put it in the chat box so that we just go on and address it once I'm done with my slides. I have to say that I am very impressed with the assignments that were submitted. A lot of us did the work perfectly well, no errors whatsoever. A few had a few errors, but once they saw the feedback and the corrections I made, they sent back the correct answer, and those ones too did a good job at it. So I'm very happy. It gives me some level of confidence that at least on this topic, again, many of us are doing well. That's good. But I have a few things that I will be stressing in this class. So before we go into that, I'll just show you the slide of the corrections where we look at what the answers are for those of us who had a few issues with solutions to the questions. Now, on your slide, you have the solutions to the questions. Questions 1 to 3 are right here. The first question asks you to find the potential difference. And from the slide that you watched or you saw last week, formula for potential difference is E divided by Q, because your E, energy, is essentially Q, your E is equal to QV, so your V will be equal to E divided by Q, 0.5 volts. Everybody that attempted this question got that number 1, and everybody also got that number 2. So that's good, that's correct. Now, number 3, a few people had issues converting megajoules to joules. Megajoules, you have to always work in SI units. The SI unit for energy is joules, it's not megajoules. So, and 1 megajoules is 1 million joules. I saw somebody who used one joule to be 1 million megajoule. That is not correct. That one is for microjoules. So in that instance, you have to be careful of your conversions. 1 million megajoule. As a matter of fact, 1 million of any quantity at all will make a mega of that quantity. So 1 million watts will make a megawatt. 1 million seconds will make a, do we have megaseconds? No, but 1 million of anything will make a mega of that. So please take note of that. That was where a number of people had issues. So having said that, your charge has to be found first. And your charge is the energy supply divided by the potential difference. That's the energy in joules. When you do that, you get 25,000 coulombs. And your current Q divided by T gives you 83.33 amps. So that is the correct solution to that question. Everybody who attempted this and had issues, I have referred to you with feedback. So I believe that even those who had errors doing it can now do it by themselves. And then the last 2 questions that we had was to test our knowledge or what we remember from our Ohm's law. That was what those were about. And our Ohm's equation is V equals IR, meaning that our R is V divided by I. So 4A, for instance, had asked us to find resistance, and that is simply V over I. That is 30 ohms. And for 4B also, you were asked to find current if the voltage was changed. So the same resistance you found in 4A is what you're going to use for 4B. And you get 7.33 amps. Now for number 5. Number 5A, many of us got our 5A right. 5A was good, but a number of the people had issues with 5B. And the issue they had was in converting their minutes to seconds. Converting 20 minutes to seconds. A number of us did not convert our minutes to seconds. Please, SI units for time is always seconds. So even if you are given in hours, you must convert it to seconds back. So our conversion of 20 minutes to seconds will give us 20 times 60 seconds. That, I believe, is 1,200 seconds. So multiplying that with the power that you have, not forgetting that power is current times voltage, and your electrical energy is current times voltage times time. So that means the current and voltage there is already what you have in 5A. So the power you have in 5A multiplied by the time gives us 1.152 megajoules. Or if you want to write in SI units, 1,152,000 joules. So those are the solutions to the question that we had. Now to a few tips or a few things I noticed that I want to quickly stress for everyone. 1, in defining current, electric current, let us not forget that our definition must include a time factor. What do I mean? If you define electric current and you just say is the flow of charges, there's nothing about time in what you have said. That will not be correct. But the correct thing to say is that electric current is the rate of flow of charges. Rate is what measures the time. Rate is what measures the time, and that is what current is about. Current is about the quantity of charges that flows across a point in a circuit per time. Please do not throw the time factor away. It will be painful if you define your electric current so well or seemingly well, but you have left out the time factor and you have not defined anything at all. Please take note of that. The other thing I want to also mention is that there's a difference between Q here, charge Q, and the quantity of heat Q. Last lesson was on heat energy. And there we were looking at, you use Q as heat energy. Here, this is electric field. Q here does not represent energy. Our energy here is E, please. I saw someone who used Q. Q here means quantity of charge. So when you are doing your calculation and you put Q equals, what you are telling me is that quantity of charge equals what you have put there. And if that is not equal to the quantity of charge, then you'll be wrong. So please take note of the symbols that we use, particularly when you have the same symbol being used for different things across different topics in physics. Q here means, under electric field, Q means quantity of charge, nothing else. Under heat energy, your Q could mean heat energy. Stands for heat energy there. So let us take note of those things. Let us not confuse ourselves with those things. So thank you. Having said that, I'll be taking a few questions for those of us who have questions. So we're going to stop sharing. If you have questions, I believe you have typed your questions. And Harry Daniel, I believe that the solutions you have seen now can help you. I saw your work at the nick of time. Even though the timeline I gave you was on Friday, you submitted your own work at the nick of time. Good, you tried. So the solutions are giving you. So I'm going to unmute you now, Dari, so that you can say whatever it is. You ask a question that you want to ask.
No. I knew the answer to those questions, but then I could not finish everything before 2 p.m. So I just had to do the first two.
You knew the answer, but you could not finish for a work you had since Wednesday last week. That's not acceptable. Any other person wants to ask a question? Yeah, Leslie, I saw your correction. That's good. I just saw it this morning, but I see that you have corrected your work. That's good. Chirindu, any question? I just sent you a mail this morning also, and I believe that the correction I have just shown on your slide will show you where your errors are. Chirindu, anybody has any question? I just believe that you all are right. You all are very, very fine with electric field. That's good. That makes 3 topics down. Okay, Leslie has a question. Yes, Leslie.
So, you know, mini Joe and micro Joe. That's the second one. So it's very hard to distinguish them when we're not actually writing it.
Okay, let me give you the symbols. The one that anything mega, we use capital M in front of the symbol for the unit. So if it's megajoules, it will be capital M before the joules. If it's megawatt, it will be capital M before the watts. Whenever you see capital, that is mega. But when you see small m, for instance, small m is milli. Just as small m before meters is millimeters. Small m before watt is milliwatts. That's the difference. And then for the micro is the one that looks like a curly U, like that funny Greek letter mu that we put in front of it. That's the one that represents micro. So that's how to differentiate them. Does that answer your question?
Yes, sir.
Good. Any other person? Okay. Everyone is fine. All right, that's good to know. So we will look at something else this week. Your lesson for this week will be uploaded like before the end of today or maybe latest tomorrow morning. That will be fine. All right. Thank you. Get ready for the next class. That's the end of this class. You get ready for your math lesson that will be coming up shortly.